Section D, finding a quadratic from its graph. In this video, we're going to focus on how to find the equation of a function given the graph of that quadratic function. The best way to learn this section is just simply through examples. So let's look at example number 1. We're going to start with A. Here we're given a graph of a quadratic. Best thing to do is write down what information is presented or given to you in this graph. Well, I know the intercepts. I know my x-intercept is -1, 0, and my second x-intercept is 3, 0. Also know my y-intercept, which is 0, 3. Since I know my intercepts, I think it would be best thing to use is my intercept form of the function of the quadratic equation. Remember, that's y equals a times x minus p times x minus q, where p and q stands for my x-intercepts. So let's plug in those x-intercepts I'm given. Let's replace p with -1 and q with 3. Simplifying this down, I end up with my equation as y equals a times x plus 1 times x minus 3. Now I'm going to use the next bit of information I'm given. I was given my y-intercepts, and I know that a must be negative since it is concave down function. So given these two bits of information, let's figure out what a is. To find a, let's use the point we have not used yet. Now you need to tell them what point you're using. So I'm going to say when x equals 0 and y equals 3, then I'm going to put in my equation, substituting in 3 in place of the y and 0 in place of the x, simplifying down and solving this equation for a. Now notice from my other information, a should be a negative. I'll check and make sure I get a negative value. So a is -1. Check. That should be negative. Now you go back to your equation, and I need the y and the x variable to remain. So all I'm going to do is go back to my intercept form, replace a, p, and q only in my final answer. Simplifying down, and I get my answer as y is equal to negative parentheses x plus 1 close parentheses x plus 3 close parentheses. One way to find the equation given the graph. Okay, now let's try example B. Now example B is slightly different because what was given to us is just 2 points. We're given the vertex, which is 2, 0, and we're given a y-intercept of 0, 8, and it's facing up, concave up, so we know a must be positive. So since I'm given the vertex, I'm going to use the vertex form of the equation this time. Vertex form is y equals a parentheses x minus h close parentheses squared plus k. Okay, where h and k is my vertex. So in place of h, I'm going to plug in 2, and in place of k, I'm going to plug in 0. Simplify that down. Now that I know what that h and k is, I need to figure out a. So I'm going to use the other point given to me, replace x with 0 and y with 8, and solve for a. A is 2. I'm going to check and make sure that it's positive. And then finally rewrite my equation in vertex form, placing only the a, the h, and the k. Since k is 0, do not write the 0. Simplify your answer. Okay, our next example is a little bit different. Let's see what's given here. Oh, we're given the axis of symmetry, which is x equals 1, but not the vertex. We're given one x-intercept, but not the second, and we're given the y-intercept. So in this case, I'm going to use my knowledge that the axis of symmetry is the midpoint between the two x-intercepts. And I recall that we have a formula for axis symmetry where x is equal to p plus q divided by 2. And I know one of my x-intercepts, so let's call -2p. So I have 1 equals -2 plus q over 2. I'm going to solve this equation for q, and that'll give me my second x-intercept. So I know q must be 4. So I'm going to rewrite my intercept form of the equation, replacing p with -2 and q with 4. Using my only point I haven't used yet, which is my y-intercept, I'm going to figure out a. So if x is 0 and y is 16, what would a be then? Well, 16 equals a times 2 times -4. Simplifying that down, I get a is equal to -2. Well, it is concave down, so a should be negative. Remind my equation in intercept form, and here's my final answer. Example 3, we're given x-intercepts of 4, 0 and negative 3, 0. And we know it passes through a point 2 and negative 2. So I'm given intercepts. So I'm going to start with the intercept form of the equation. And I'm going to substitute in place of p, 4, and q, negative 3. Now I'm going to use the point I have not used yet. And I'm going to replace y with negative 20 and x with negative 2, positive 2, sorry, and solve for a. And I find that a is equal to 2. So now I'm going to write my equation in intercept form. But this time I can't leave it like that. I'm going to have to rewrite it so it gets into standard form. So I'm going to start by full method, multiplying the x minus 4 times the x plus 3 and simplifying that down. And then I'm going to distribute the 2 to all terms inside the parentheses. And that will be my final answer. So the equation in standard form is y equals 2x squared minus 2x minus 24. Example 4. Find the equation given this information. So we're given a vertex and the x-intercept. So since I'm given the vertex, I'm going to use the vertex form of the equation, replacing my h with 3 and my k with negative 2. Simplifying down and using my y-intercept point. So when y is 16 and x is 0, I'm going to solve for a. A is positive, which is correct since it's concave up. Replacing my a, my h, my k, and here's my equation in vertex form. Example B. Same thing. I'm given the vertex, and this time I'm given the x-intercept instead of the y-intercept. It does not matter. I'm going to use the exact same method. I'm going to use my vertex form of the equation. And I note here that a is negative, so it should be concave down. Plugging in my vertex. Now I'm going to use my x-intercept point. So I'm going to let x equal negative 2 and y equals 0 and solve for a. A is equal to negative 1/2. A should be negative, so that's good. Go back to my vertex form, replace a, h, and k, and I am done.